Get ready, because we're diving headfirst into one of Earth's most terrifying, yet utterly fascinating, natural phenomena, the megatsunami. Imagine a colossal wall of water, unlike anything you've ever seen, surging across vast oceans with unstoppable force. This isn't just a big wave, it's an event with the power to redraw coastlines and utterly destroy entire cities in a flash. Scientists globally are studying these giants, unraveling their mysteries and calculating the devastating potential impact. It's a stark reminder of our planet's immense power, and the critical need for global awareness and preparedness against such an extraordinary force. What exactly separates a regular tsunami from a true megatsunami? It's all about scale and origin. While typical tsunamis are usually caused by underwater earthquakes, generating waves that are often less than 10 meters high in coastal areas, a megatsunami is a different beast entirely. These incredible events are triggered by colossal, rapid displacements of water, usually from massive, sudden landslides, either underwater or from land collapsing into the ocean, or even catastrophic volcanic eruptions. The result? Waves that can reach extraordinary heights, often tens or even hundreds of meters, especially near the source. It's a localized, explosive power that dwarfs traditional seismic waves, making them far more destructive. One of the most terrifying triggers for a megatsunami is a colossal underwater landslide. Imagine vast sections of continental shelf or oceanic islands suddenly collapsing and sliding down into the abyssal depths. This immense displacement of Earth beneath the ocean's surface acts like a giant paddle, pushing an unimaginable volume of water with incredible force. The sudden, massive movement generates an immense ripple effect, creating a wave that rapidly propagates outwards. Scientists monitor unstable underwater slopes and active fault lines, analyzing the geological conditions that could potentially lead to such a catastrophic event. The sheer scale of these submerged landslides is almost impossible to comprehend. Another incredibly powerful source for megatsunamis originates from the fiery heart of our planet, volcanic eruptions, specifically those on oceanic islands. When a large volcanic island's flank becomes unstable and collapses catastrophically into the ocean during or after an eruption, the resulting displacement of water is absolutely immense. This isn't just a small rockslide, we're talking about cubic kilometers of rock plunging into the sea, generating a wave that can propagate across entire ocean basins. Scientists have identified several such mega-collapse zones, meticulously studying their geological history and potential for future events. The energy released is truly mind-boggling. Once unleashed, these monumental waves begin their journey across the ocean, moving with astonishing speed and possessing truly unimaginable energy. In the deep ocean, a megatsunami can travel as fast as a jet plane, reaching speeds of over 800 kilometers per hour. Think about that, it's racing across entire ocean basins at incredible velocity. While the wave height might be modest in the open sea, as it approaches shallower coastal waters, the energy compresses, and the wave grows dramatically, towering to potential heights of 100 meters or more. It's a breathtaking demonstration of raw physics and the sheer power of displaced water. The scale is just mind-blowing. Now, let's picture the horrifying moment a megatsunami slams into a coastline. This isn't just surf, it's an impenetrable wall of water, dozens or even hundreds of meters high, smashing into the land with unimaginable force. Coastal cities and infrastructure stand absolutely no chance. Experts describe the initial impact as an instantaneous, complete devastation. Imagine entire cliffs collapsing, beachfront buildings simply disintegrating, and the very landscape being dramatically reshaped in seconds. The sheer volume and velocity of water create a destructive force that can scour away everything in its path, fundamentally altering the geography of the affected area. It's an apocalyptic scene unfolding in real time. After the initial impact, the wave's incredible energy continues its devastating journey inland, turning bustling coastal streets into raging rivers and tearing through urban centers. We're talking about multi-story buildings being utterly ripped from their foundations, cars and debris tossed around like toys, and entire neighborhoods submerged under meters of turbulent, debris-laden water. The destructive power continues far beyond the immediate coastline, pushing inland for kilometers, leaving behind a trail of utter ruin. The force of the water alone can collapse structures, but the sheer volume of debris carried within the wave adds another layer of unimaginable destruction. It's a complete erasure of human-made environments. The terrifying reality of a megatsunami means that evacuation becomes an almost impossible race against time. Unlike a slow-moving hurricane, the warning window for a locally generated megatsunami could be incredibly short, mere minutes to perhaps an hour or two. Imagine trying to evacuate millions of people from densely populated coastal cities with such a limited time frame. The logistical nightmare of traffic jams, overwhelmed emergency services, and the sheer panic would be immense. Preparedness plans, efficient communication systems, and designated high-ground routes are absolutely crucial, but the scale of the threat demands rapid, decisive action that is often difficult to achieve. It's a true test of human organization. Our primary defense against these colossal waves lies in sophisticated tsunami warning systems. These networks utilize an incredible array of technology, including seismic sensors that detect underwater earthquakes, and a crucial component, deep ocean assessment and reporting of tsunamis, or dark buoys. These buoys monitor changes in sea level with incredible precision, sending real-time data via satellite to warning centers. Coastal sea level gauges and GPS receivers further refine these measurements. When combined, this global network provides vital minutes, or even hours, of warning for distant tsunamis. It's a phenomenal feat of engineering, constantly working to give communities time to react and save lives. While our warning systems are incredibly advanced, megatsunamis present unique challenges that test the very limits of our current capabilities. Because many megatsunamis are triggered by localized events like landslides or volcanic collapses, often very close to shore, the warning time can be drastically reduced to mere minutes. This local tsunami scenario makes detection incredibly difficult before the wave strikes. Current dark buoys are spread across vast oceans, designed for distant events. Predicting the exact moment of a massive flank collapse or underwater landslide remains incredibly complex, requiring sophisticated modeling and continuous geological monitoring, which is a monumental task. The speed and proximity make these events particularly insidious. Now, let's talk about a scenario that has captivated scientists and sparked intense debate: the Cumbre Vieja volcano on La Palma in the Canary Islands. Geological studies and models have long explored the possibility of a catastrophic flank collapse here. While the volcano is currently stable, some research suggests that a future major eruption could potentially destabilize a large section of the island, sending an enormous mass of rock plunging into the Atlantic Ocean. The implications are staggering, with simulations predicting a colossal megatsunami that could propagate across the entire ocean basin. It's a compelling, if frightening, example of the potential for such events to be triggered. The scientific community rigorously debates the probability, but the potential is undeniable. If a La Palma megatsunami were ever to occur, the implications for distant coastal regions are absolutely staggering. Models predict devastating impacts on the east coast of North America, including major cities like New York, Boston, and Miami. Imagine waves reaching dozens of meters in height, pushing far inland, inundating densely populated areas. European and African coastlines facing the Atlantic would also experience profound devastation. The sheer density of population and critical infrastructure along these coastlines makes them incredibly vulnerable. It's a scenario that underscores the interconnectedness of our planet's geological systems and the urgent need for transoceanic disaster planning. The vulnerability is truly immense. In the future, advanced satellite technology might play an even more critical role in detecting and tracking these monstrous waves. Imagine a network of highly sophisticated satellites continuously monitoring ocean surfaces for subtle changes in wave patterns and sea levels that could indicate a propagating megatsunami. These eyes in the sky could provide crucial data to refine warning models, track wave trajectories, and give more precise estimates of arrival times for distant coasts. While local triggers will always be a challenge, global satellite coverage offers a promising avenue for enhancing our long-range warning capabilities, potentially adding precious minutes or hours to evacuation windows. It's truly our ultimate vantage point. Once a megatsunami strikes, the aftermath is a scene of unimaginable devastation, presenting unprecedented challenges for rescue and recovery operations. Rescue helicopters would scramble over vast areas of flooded streets and obliterated buildings, searching for survivors amidst the chaos. International aid agencies would face a logistical nightmare trying to deliver essential supplies, medical assistance, and shelter to millions of displaced individuals. The long-term recovery efforts would span decades, demanding colossal resources to rebuild infrastructure, homes, and entire communities. The human cost, both in lives lost and livelihoods destroyed, would be truly staggering, testing the resilience of entire nations. It's a monumental test of human spirit and cooperation. In the face of such an overwhelming threat, coastal cities must now reimagine their very existence. The focus shifts to building for extreme resilience. This means designing elevated structures, constructing massive sea walls and surge barriers, and developing innovative green infrastructure solutions to dissipate wave energy. Urban planning needs to prioritize vertical evacuation routes and designate safe zones on higher ground, ensuring clear pathways for rapid egress. Investing in robust, tsunami-resistant building codes and early warning system integration is no longer a luxury, but an absolute necessity. It's about adapting our built environment to coexist with the raw power of nature, minimizing future catastrophe. It's crucial to remember that megatsunamis, while terrifying in their potential, are incredibly rare events on a human timescale. We're talking about phenomena that occur perhaps once every few centuries or millennia. However, on a geological timescale, they are an inevitable part of Earth's dynamic processes. Our planet is constantly evolving, with continents shifting, volcanoes erupting, and coastlines eroding. The rarity of these events in human history does not negate their potential for future occurrence. This perspective helps us understand that while we might not witness one in our lifetime, the geological conditions that foster them are always present, underscoring the need for long-term vigilance. Earth's history is written in these dramatic shifts. Tackling the threat of megatsunamis demands a united, global front. No single nation can adequately prepare for, or respond to, an event that could send waves across entire oceans. International cooperation is absolutely paramount. This means shared scientific research, collaborative warning system networks, and harmonized disaster response protocols. Joint exercises, real-time data sharing, and continuous technological advancements are essential components of a truly effective global preparedness strategy. Organizations like UNESCO's Intergovernmental Oceanographic Commission play a vital role in coordinating these efforts, building a collective defense against nature's most extreme forces. It's an inspiring example of humanity working together. So, are we truly ready for the megatsunami that could one day strike? The reality is complex. While our understanding and technology have advanced dramatically, the sheer scale and speed of these events present an unparalleled challenge. We've explored the terrifying potential, cities destroyed, coastlines reshaped, millions at risk. But we've also seen the incredible efforts in science, technology, and global cooperation aimed at mitigating this threat. The key takeaway? Awareness, continuous research, and proactive preparedness are not just options, they are necessities. By understanding this awe-inspiring, destructive force, we empower ourselves to build a safer, more resilient future. The conversation must continue.